Hey there, Peacock. We got a do now for today. It's based on the 1980s game show called Press Your Luck, which basically involved a spinner. To simplify it, we'll say the spinner looks like this. It's got four spaces. These little guys are called whammies. They mean you lose. And if you land on big bucks, you win. Woo! So calculate the probability for the following situation. Through the course of the game, you got three spins. You get to spin the spinner three times, and we're going to find the probability of landing on big bucks exactly each of the following times. 0 times will be one calculation. 1 time exactly will be a separate calculation. 2 times, 3 times, and so on. Binomial theorem, as seen here, we saw that last time. And ready, set, go ahead and hit pause on the video while you figure out your answers for those 4 separate calculations. All right, so the probability of success on one spin, let's start with that. We're looking at the spinner, so there's 4 spaces here. 3 of them are losing spaces and 1 is a winning space. So that's going to tell us our probability of success. So the equation for 0 times of success, 3 total spins, 0 successes. Probability of success is 1/4 because only one of the 4 spaces you win. 0 successes, because this will be the exponent, that's the number of successes. And then the blue part is for failures, so there's 3 losing spots out of the 4, and this time we are losing 3 times out of our 3 total spins. Plug that into our calculator, we get 42%. And then the only thing that's going to change for the next series of calculations are the numbers that are highlighted. So if we're looking at 1 success, we're going to change that 0 into a 1, in both the red part and the green part. And then the number of losses is going to go down out of your 3 total spins. If 1 is a win, we've got 2 spins that'll be losses this time. So it also gives us 42% in the end. And then here's all of our answers. For 2 successes, 14%, 3 times is 2%. All of those are rounded off to the nearest whole number. There were decimals involved in all of those, just in case you were curious about that. So today we're taking a look at the binomial theorem. Again, our learning target is that we'll be able to calculate the probability for various outcomes, like we just saw in the do now, for a repeated event. And the most part, we're looking at the binomial theorem today, the same as what we did in the do now, same as what we did last time. There is one additional thing. So suppose we have all of the answers that we previously calculated for the number of successes from 0 successes all the way up to 3. If we were asked the following, what is the probability of getting big bucks 1 or more times? Okay, well, a couple of things that could show up. First of all, what does 1 or more times mean? Right, 1 or more refers to a variety of different outcomes. It could be exactly 1 success, it could be 2 successes or 3 successes, right? So anything larger than 1. So one approach would be to add together these different probabilities, everything from 1 and up, so 42% plus 14% plus 2% gives us a total of 58. A different approach would be that we know all of the outcomes together combined to make 100%. Right, so 1 or more, the 2 different ways we look at this, it means everything from 1 up, but also it basically means every possible outcome except not 0 successes, right? So we could just start from 100%, subtract the one thing that was not included, 0 successes, and if we did 100%, because that's the total of everything, 100 minus 42%, then that'll give us everything that's left, which is 58%. It's the exact same answer. So there's 2 different ways of thinking of this, and I labeled it as a longer option and a shorter option, and really based on the information we're given on this screen, really they're really not any different. I mean, adding 42 plus 14 plus 2 is really not that much different from 100 minus 42 in terms of length of calculation. But let's think about it from a different perspective. If you did not have these probabilities, which we just got by doing the do now, and you had to come up with those probabilities on your own in order to add together the probability of 1 success, the probability of 2 successes, probability of 3 successes, then that starts to look like a lot longer to get the 1 and everything, 1 and up. We'd have to get each of those individual probabilities and then add them together. Okay, if we extended the problem just a little bit and you thought about, I mean, 3 spins is not really a big number. What if there were 100 spins? What if we looked over the entire course of the entire game show and maybe it's like 1,000 spins, right? Well, in a situation like that, that's a lot of probabilities to add together, because it's not just 1 success, 2 success, 3 successes. That's going to keep going. 4 successes, 5 successes, all the way up to 100, all the way up to 1,000. I mean, whatever the total scope of this problem involves. And so that's a much, much more difficult thing to do unless we just subtract the 1 that we're not including, or maybe the 2 that we're not including, depending on what the question says. So in that situation, being able to subtract from 100% is way shorter. Okay. Second reason why this is an important thing for us to see comes in what's ahead of us still. So a lot of statistics deals with large scoped problems, like if you had 1,000 repetitions of the spinner, right? And so a lot of the tools that we're learning as we study statistics involve, well, we want to have a tool or a strategy that's going to work if there's like 1,000 outcomes. I don't want to have to add 999 of them when I could just subtract 1 out of 100%. So this type of thinking is something that we're going to see a lot of in the next several lessons. All right, let's just see it one more time here. Suppose you got 4 spins. The spinner is different this time. If I've already calculated all the probabilities of success, 0 successes, 1 success, 2 success, 3 success, 4 success, already is provided for us in the table. What's the probability of getting big bucks 1 or more times? Okay, well, again, we've got these 2 different approaches. You could either add 1 plus 2, the probability for getting 1 win, 2 wins, 3 wins, and 4 wins, and so on, adds up to 88%. Or we just take that 12% for 0 successes. That's the only thing we're excluding. Subtract it from 100. Okay, last thing, which doesn't really show up so much in this assignment, but if we have a table that shows us the outcomes for the various number of successes, tables are nice. Sometimes a histogram is an easier way to just get a visual of what's going on here. And so we just take those percents and scale our histogram up the y-axis with those different probabilities. And then we can make our histogram based on those probabilities. And so then we can see, wow, I mean, that's a huge difference. 0 and 1, very common, and all the others, the probability drops off really quickly. Okay, histograms is something that's coming up. We're going to come back to that, and this visual representation is going to be something that's very important for us. So let's keep that in our minds. Talk to you in the back. Have fun.